What lies in the Earth-world future for us? One of the most significant barriers keeping humanity from the stars is the speed limit of the universe. Even if we had the technology to rocket us through space on high-speed colony ships, how fast we can travel normally is limited to light speed in a vacuum. Nothing in the universe can move faster than 300,000 kilometers per second, 186,000 miles per second, and nothing with mass can reach that speed. There are, however, theoretical workarounds. One is to build a massive space station in orbit around Earth and use it to launch a fleet of sublight speeds. We could then accelerate the starships to their maximum speed using solar sail. By the time they're out of the solar system, they'd be going almost 40% the speed of light. But there's a catch. This would take decades to accomplish, so we wouldn't be launching fully fledged starships anytime soon. But we could start sending probes out into the solar system at these speeds to search for planets that might be suitable for human colonization. If we're lucky, we might find one within our lifetime. This is our channel. We make videos about space. What will the world of the future look like? In quantum physics, Rodney Kravetsky goes beyond Alcubierre warp drive. He ventures into warp bubble imagery, but believes that this space corridor lays at the last layer of vacuum fluctuation, layers of the space vacuum. His idea ventures a little beyond Alcubierre warp drive, but begins at light speed in our low-density Spacefield realm. The bubble may occur there in a future starship journey, traveling backwards in time, surpassing into superluminal speed. Let's imagine a world where we have these bubble spaceships traveling at near light speed. The only way to see them is with a special camera that can see the distortion in space-time caused by the bubble. As the ship approaches, the bubble gets bigger and bigger until it's so large that it engulfs the entire ship. At this point, the ship is traveling faster than light and has effectively gone backwards in time. Imagine seeing this for the first time. What would you think? Let me know your thoughts. If you enjoyed this video, be sure to check out my others for more science and tech stories. Thanks for watching. You see, greater than warp drive light speeds are possible in quantum physics theory. A single warp drive us, just the beginning of the Earth science. At the Kravetsky low-density corridor, infinite mass gain, interior, and time travel at light velocity cease to exist. See, Kravetsky discovered time is an illusion. It's a man-made TikTok machine that is not physical, thus doesn't actually exist. So he researched further and discovered intermediate spacefield contraction theory. This allows for faster-than-light travel. And according to this theory, the universe began at a singularity where space and time were infinitely dense, and all the matter in the universe was contained within a tiny point. As the universe expanded, space and time stretched with it. However, at the subatomic level, there is a limit to how fast particles can move. This is because the particles must move through space and time, and as the universe expanded, this limit became more and more restrictive. The particles could not move fast enough to keep up with the expansion of the universe. This caused a breakdown in the space-time continuum and allowed for the possibility of faster-than-light travel. In quantum physics theory, time does not exist at all. It's only that relativity terminology used time with its measurement with light, the speed of light. In reality, time doesn't exist. It's just that we don't have a choice but to use it because it's a human construct. So what happens to time in a black hole? Well, according to quantum physics, time stops. But why? Because time doesn't actually exist. It's just a human construct. We made it up. So what happens to energy? Is it well, yes. Energy is conserved because time doesn't stop. It's just that we don't have a choice but to use it because it's a human construct. Oh, no. Speeds beyond light speed are impossible. That's a proven fact. You can never reach the speed of light, let alone go faster than light. You can't even reach it. Why? Because it's a concession of Einstein, where all relativity journeys into a table of past, present, and future, multiple warp drives. Let us into a faster journey. Spacefield contraction is accounted by forwards, time-ship acceleration that travels to its destiny, traveling backwards against a permeated zero vacuum grid. Thus, the ship travels forwards in time, racing against a backwards space-time, the time it takes light to reach Earth relative to its distance in light years. Let's take a look at this equation. As the ship accelerates, time slows down for the astronauts on board. The closer they get to the speed of light, the slower time goes for them relative to someone standing still on Earth. This means that if the astronauts were to travel to a star system that was, let's say, 4 light years away, when they arrived, less than 4 years would have passed for them, but more than 4 years would have passed on Earth. This is because the space between the Earth and the star system would be contracted by the forward time-ship acceleration, thus allowing them to travel to their destiny, which is the star system, while traveling backwards against a permeated zero vacuum grid, which is the background radiation of the universe. This means that the ship is traveling forwards in time while the universe is traveling backwards. The faster the ship travels, the faster time goes on the universe. Thus, the ship is racing against a backwards space-time background. What would a ship made of steel look like if it was traveling at the speed of light? Well, first off, it wouldn't be made of steel. It would actually be made of Higgs boson premides with a net neutral charge. That's because, at the Higgs vacuum layer of space, there's an equal amount of positively charged particles as there is negatively charged particles. So when you combine them, they cancel each other out to zero. So a ship traveling at sub-zero vacuum fluctuations, which is a below-zero ground state in the standard theory, would then have a net positive charge. And since there's no speed interference, there's nothing to slow it down or stop it. It just keeps going at that speed forever. It also forms a corridor, kind of like the Alcubierre warp bubble, but instead of being a space-time distortion that allows for faster-than-light travel, it's an environment speedway passage corridor that allows for sublight speed travel. In other words, a lane that lets you pass through the Higgs vacuum without getting slowed down by the Higgs boson. When we research further, we don't have to imagine that our superficial standard theory already omits to a positive-negative quantist energy nature. The negative ground field may be admitted to an existing negatively charged field layer, where the Higgs field lays. This is where Michael's Alcubierre warp bubble is formed in Spacefield mechanics. Though Mr. Alcubierre warp bubble is a mathematical invention at the Higgs vacuum field, the space field continuum may flow towards Hubble space. In other words, at the deepest level of the vacuum, there might be a flow towards the positive side. There might be a repulsion, a negative resistance against the positive side, which would explain why the universe is the way it is. Because if there is a negative resistance at the deepest level, then that would manifest as a positive force, and that positive force could be the driving force behind the expansion of the universe. I think this is a very interesting idea that we should explore further. Did we just find Earth's version of a wormhole? Well, not exactly. What we did find is an hour of a negatively altered vacuum field, and that's something that scientists have never seen before. It's also something that theoretically should not exist. When our sun was born, it created a massive explosion of energy that blasted a hole in the fabric of space. That's what's known as a worm. And wormholes are all around us. They're just invisible. You can't see them. We know they're there because of their gravitational effects. But this one was different. This wormhole is like a cosmic drain. It sucks in light and matter and energy and time itself. And for a brief moment, it actually worked as a time machine. For 48 hours straight, we watched this wormhole do its thing. And then just as suddenly as it started, it stopped. The wormhole collapsed and our universe was thrown back into balance. This is incredible. It's amazing. It's also terrifying. Because if we can create a wormhole, then theoretically, so can other universes. And that means that at some point, one of them might collapse into our own.